Yeah, welcome back. As a continuation, I think this is the part B of the previous presentation on the problem solving on galvanic cells and electrolytic cells. So I think we got cut when we were still explaining the EMF, which is the initial reading on the voltmeter. That is the EMF. So we know that M is magnesium, therefore it will be negative 2.36, and this one is chlorine is given. Then we find this one. The last question on the question paper was saying 8.4. In this case, 8.4. This is the question. Long statement, but very important. The concentration of Cl minus is now increased. So what will happen to the value calculated in question 8.3.2? Write down the increase, decrease, or remains the same. Give reason for the answer. In many cases, they say find out whether this one is part of the product or part of the reactants. If they are reactants, then we know that now we can have the notion of saying the EMF is directly proportional to the concentration of cathode half cell, which is your this case the reactant, or the EMF is inversely proportional to the concentration of the anode half cell. With both, then they are reactants, but when they are products, then we have to use Le Chatelier's principle now, like in this case. So Le Chatelier's principle here, it will be now in the balance equation, will be now X react with chlorine to chlorine gas to form 2Cl minus plus X2 plus. This is, remember, this is magnesium, so no problem now. Fine, this is the case. Now we are increasing the concentration of this one. Since this one can be reversible, yes, then if you increase the cost of the products, what says Le Chatelier? Le Chatelier says now a reverse reaction will be favored. Therefore, if you increase the concentration of chlorine ions, reverse reaction is favored. If the reverse is favored, it means that now the EMF will have to decrease, because the EMF is increasing if you are favoring the forward. So your first will say the EMF decreases. EMF decreases, because they were saying to you here, write down increase, decrease, or remains the same. So it will say decreases. Give reason for your answer for the second mark. It will decreases because why? Reverse reaction is favored. Increasing concentration of Cl minus favored the reverse reaction. So reverse reaction is favored. That is very important. But if you increase one of the reactants, you know that you are favoring the forward. So that's what that will increase the EMF. Always check which side. So take this one as a reversible reaction, then you'll understand. Favoring the forward, EMF increases. Favoring the reverse, EMF decreases. I hope it's clearer now. Thank you. Let's move to electrolytic cell. So the electrolytic cell, which is question number 9. Question number 9, we can start that one on a new page. Yes, let's use a new page here. Now the electrolytic cell was saying to us here, very important question. They are saying to us, in the electrochemical cell below, carbon electrodes are used during the electrolysis of concentrated sodium chloride. Find solution. Now we are given this. We can even analyze this, what is given, before you can even attempt the question. Chlorine is always formed at the anode. That's what you should know, please. Chlorine is formed at the anode, therefore the cathode will have hydrogen. Obviously, then I already know that gas A is hydrogen, and then electrode P is the anode, which is the positive electrode. Therefore, I already see that, therefore X is positive and then Y is negative. So fine. Then I'm given this concentrated sodium chloride. So I've already answered few questions, or most. Then define the electrolysis. Electrolysis, remember, is a process. That is 9.1. So this one will be a process a process of converting electrical energy to chemical energy. Electrical energy to chemical energy. So a process whereby a chemical reaction is forged by inserting, in this case, electrical energy, fine, or using electrical energy. So we forge chemical reaction using electrical energy. 9.2, according to this one, they say, is the cell illustrated above galvanic or electrolytic cell? It's obvious this one, we are in the electrolytic, it will be electrolytic cell. Last question is electrolytic cell. Fine, the electrolytic cell. So now this is say give reason for your answer. Then you can see that now we are using a DC source. You can just say DC source used, or electrical energy source is used, or electrical energy is now supplied to the cell. So just the expression showing that now the output, the input is the electrical energy. What is the polarity of the terminal X? We have already analyzed that one to say since chlorine is formed at the anode and anode is positive, therefore X will be positive, because they say choose positive or negative, it will be positive. Fine. 9.4. 9.4, they are telling us to say, according to this one, write down the half reaction taking place on the surface of the electrode Q. Electrode Q, remember we said, is the cathode. That's where hydrogen will be formed. Obviously it will be formed from water. Fine, so water, we go to the table, reduction table, and copy to say water molecule will gain 2 electrons to produce 2 OH minus plus hydrogen. That will be the case. Yes, that's the balance equation, the one that is taking at this one, the cathode. Now there can be a question, oh sorry, let me not preempt, maybe it might be coming. Yes, we have written that direction. Now they say, what will the pH of the solution in the cell be after the cell has been working for some time? Now, will it be greater than 7, equal to 7, or less than 7? That one is obvious. You look at this one. It will make the pH to be now greater than 7. Greater than 7. We write that one greater than 7. Then, if they say give reason, you just say OH minus is formed. That's what they say. OH minus is formed. OH minus, or the base is formed. That's the case. OH minus or a base is formed, because if you include the spectator ions, it will be sodium hydroxide. Get 2 marks there, one for greater than, and then the other one for OH minus is formed. Refer to the table of standard reaction potential to explain why sodium atoms are not formed on the surface of the electrode of this cell. No, that one is easy. You go to the table, you will find these 2 reactions to say sodium ion will gain 1 electron to form sodium if it's reduced, and this is negative 0.83 volts. And then this one, water, if you go and check on the table, you find this, that water is forming 2OH minus plus hydrogen, then dot, you find that the electrode potential of this one, this is for water, I'm mixing them, and then this one will be negative 2.71. Fine. Remember, when they are fighting for electrons, because these two sodium ion and water, they are fighting for electrons. They are both oxidizing agents, but now they are fighting for which one is stronger now will win the battle. The big one. So big one is negative 0.83 is the one that will win the battle in the fight for those electrons. Therefore, you tell the examiner that there is no way that sodium ions will be reduced in the presence of water. Because why? Water is a stronger, will be a stronger oxidizing agent. Than sodium ions. Or someone can say sodium ion is a weaker oxidizing agent than water. You get 2 marks for saying that. Then the last part will be, now you have for option as well. You will now say, therefore water, therefore, let me just say therefore, water is reduced to hydrogen. Or someone can say, therefore, sodium ions will not be reduced. That one also is taken into consideration. That's the last part to get 1 mark. It's either you say, therefore, water will be reduced to hydrogen gas, or sodium ions will not be reduced. This first part, water is a stronger oxidizing agent than sodium ion, or if you start with sodium ion is a weaker oxidizing agent than water. So that is how we reason this one. What informs that one? We look at the strength. In this case, say the two are oxidizing agent. Which one is a stronger one? The one with the greater potential, isn't it? Electrode potential. That's how we win this one. I hope and believe that at least by now it's becoming very clear, especially in explaining when they say use reducing abilities or use oxidizing abilities. If you are using reducing abilities, you look at the right hand side. Therefore, you look which one is a stronger reducing agent than the other one. So will be the one with the least, anyway, electrode potential will be the stronger reducing agent than the other one. So because they say which one will lose electrons before the other one. So you can't let the big one lose electrons while the small ones are there. But if they have to gain, the big one gain first, and then the small one will suffer the defeat in that case. So that's how we use this explanation. Use the table, electrode potential table, to answer this question. The important advice is that because there are 2 electrode potential tables, the majority of chemistry people, they are just slashing 4A and use 4B. It's easier to use, but if you don't have a problem with using both, no problem, you can use both, but for convenience sake, you can use 4B. Then it's very easy. It always starts with the negative part and goes to the positive part. You know that at the bottom of that table, there will be stronger oxidizing agent and weaker reducing agent on the right hand side. And then if you go up, then there will be the weakest oxidizing agents on the left, and then the strongest reducing agent on the right. I hope you understand that. Until the next session, I hope and believe that at least now it's becoming clearer and clearer, and also in terms of explanation as well. So electrolysis of sodium chloride, very important. Base is formed. If they talk about the indicators, it will favor the color which is formed in the presence of a base. Until the next session, don't forget to subscribe and spread the gospel. Little information is dangerous. Therefore, the more you're exposed, is the more you become more equipped in physical sciences, both paper 1 and paper 2. Do as many exercises as you can. You become more enlightened and more exposed and more capacitated. Until we meet again, thanks a lot. Bye for now.